So here's another one. Y double prime plus xy prime plus 2x minus 1 times y equals 0. We got some initial conditions. Y of negative 1 is 2, and y prime of negative 1 is negative 2. So that means if we're going to try to solve this, we're going to need a number we can put into our Taylor series for y double prime. And so if we were going to do that, y double prime equals negative xy prime minus 2xy and then plus y, right? That's just this equation solved for y double prime. So, but we've got numbers we can fill in for that. So negative x is negative of negative 1, so positive 1 times y prime, which is, where is it, negative 2, minus 2 times x, but x is negative 1, times y, and y is 2, and then plus y, which is 2. So we got 1 times negative 2 minus 2 times negative 1 times 2 plus 2, and if you do all the arithmetic on this, that comes out to be 4. Y triple prime means we need to look at this expression and take a derivative term by term. So that's negative x y double prime minus y prime times the derivative of x, which is just 1, so minus y prime, and then first d second plus second d first. Here we got 2x times y prime plus y times 2x, or actually minus y times 2x, and then plus y prime, only no product rule in that term. How about that? So we got negative of negative 1 times y double prime, which was 4, so 1 times 4, minus y prime, well that's minus negative 2, so it's going to wind up being plus 2, and then minus 2x times y prime, well the 2x is 2 times negative 1, and y prime is given as negative 2. So, and then minus 2 times y, that's 2 times 2, and then plus y prime, which is negative 2. So if you add all this up, it comes out to negative 4, and we've got our y triple prime. Y 4 derivatives, right? So take derivative of this term, negative x times y triple prime plus second d first, so minus y prime. The minus is from the negative in front of the whole thing. Derivative of this term, y double prime. The derivative of this term, using the product rule again, negative 2 times first d second x y double prime plus second d first, that's just y prime times 1. And then minus the derivative of this term, minus 2y prime, and then finally derivative of this term, y double prime. So filling in all the numbers, and I think hopefully you could follow that without my helping, but negative 1 here, this one calculated to be negative 4, so negative of negative 1 times negative 4, minus 4, we calculated that one to be, minus 4, we calculated it to be again, minus 2 times negative 1 times 4 times negative, or plus negative 4, and then minus 2 times negative 4, and then plus positive 4. So if you do all the arithmetic on that, you come up with 8. So the first 5 terms, we got 2 from this initial condition, plus negative 2 over 1 factorial times x minus 1, x minus negative 1, so it would be x plus 1, and then 4 from this over 2 factorial times x minus negative 1, x plus 1 if you want, squared, and then this negative 4 over 3 factorial times x plus 1, x minus negative 1 if you want, cubed, and then plus 8 over 4 factorial times x plus 1 to the 4th. And if you simplify that a little bit, you get 2 minus 2 times x plus 1 plus 2 times x plus 1 squared minus 2/3 times x plus 1 cubed plus 1/3 times x plus 1 to the 4th. And we could do more, but it would require more derivatives. Now it just depends on how accurate we need this to be. You may recall alternate series, your answer is as good as the first neglected term if you look at the remainder. So that's it for this one, although to do more further out than x plus 1 to the 4th would require more derivatives.
So very difficult.
And that would be, I don't know, difficult but tedious.